Good evening, folks. Welcome to Constellation Tour number 15. We're going to go over Hercules tonight, and I've got the software set up for July 6th, 2020 at 9:50 p.m. approximately. So you're probably not watching this on that date. That's okay. I have it set up for that particular date because Hercules is best viewed in the summer months, June, July, and August. So July being in the middle of that, that's when Hercules crosses the meridian. Get my notes out here. My name's Bill Breeden, and I'm glad to share these constellation tours with you. I'm slowly but surely making my way across the entire sky, one constellation at a time. So join me tonight for tour number 15, Hercules. I'm using Stellarium, and I have it set up with a 60-degree field of view, simulating a naked eye view from a suburban location with moderate light pollution. And tonight we're looking eastward toward the horizon, and you can see that Jupiter and Saturn here are rising in the southeast on July 6th. Really low, so probably wouldn't be the best view. But we're going to talk about Hercules tonight. Now, where Hercules is near the 38th line of declination, of northern declination. So with us observing here in the Midwest at a latitude of 38 degrees, that means that Hercules passes through the zenith. I mean, it's really high up. So here tonight in early July, Hercules is going to be nearly straight overhead. So I'm starting looking east because it's actually going to be a little bit off the zenith, a little bit down toward the east a little, which makes it a little bit easier. The telescope will still be pointed pretty high up though, so it could be a problem. You might want to observe Hercules a little bit later in the evening when it's crosses the meridian and begins to set a little bit toward the west. It might be a little easier to get to. So let's start by finding Hercules. Hercules is located between two bright stars, Vega and Arcturus. So let's find Vega. Vega is going to be really, really high up in the summer months. Vega has a very high northerly declination as well, which means it passes pretty high up. Here it is right here. Let's see how high up that is. 60 degrees up in the sky tonight. So, and let's find Arcturus. Now to find Arcturus, remember you look north for the Big Dipper and you arc to Arcturus. So there's the Big Dipper right there. And we follow the arc and we arc over here to Arcturus. So let's look really high up and look at the area of the sky between Vega and Arcturus. There we go. So now we're really looking high up and we're in the direction, let's take a look here. This is southeast. So we're really looking high up. That's why I keep moving the star field for you, is to simulate that you're looking way up high. Let's see just how high we're looking. And this spot here is the zenith. That's the point straight overhead. So here's Vega, 60 degrees up above the horizon. Here's Arcturus, about 60 degrees up above the horizon. So just between those two, you're going to look for a rectangle of stars right here. This is called the keystone. That's how you find Hercules. So let's turn on our constellation lines. And here you see Vega, and here you see Arcturus, and you see Hercules is right here. So that's a pretty dominant constellation from mid-northern latitudes because he does cross through the zenith. So he remains in the sky for many months. So if you don't get a chance to see him in June, July, or August, you can see him pretty well in April and May in the east, and in September and October in the west. So you got a long stretch of time to observe Hercules. So let's have a look at the area of sky that encompasses Hercules. As you can see here, Hercules is a very large constellation, a very large patch of sky here that looks like part of it. Now, not quite. Corona Borealis is actually hitting the zenith tonight, but there is a part in upper Hercules here that is basically at the zenith. So that's incredible. Very large area of sky here. So what do we want to look for in Hercules? I like to start with one of my favorite double stars that I think competes very well with Albireo, and that's Razel-Gethy. Now, I'm going to try to do this from memory before I cheat here. So here's the keystone of Hercules. And let's see if I can find... I usually start by looking for Ophiuchus. And here's the claws of Scorpius. Here's the bottom part of Ophiuchus. Here's the top star of Ophiuchus. Let's turn on the constellation lines for a moment. I usually look for the claws of Scorpius, the bottom part of Ophiuchus. That leads me to the top of Ophiuchus here. And this star here is called Razelhage. And if you'll notice, there's another bright star that's not too far from Razelhage in the direction of Hercules, and that's this star right here. If memory serves me correctly, that is Razel-Gethy. So let's have a look through the finder. Okay, there's Razelhage. There's Razel-Gethy right there. Let me see, was I right? Let's see. Yeah, there's the top of Ophiuchus, so that's Razelhage, and this one is Razel-Gethy. That is a really nice double star. Let's have a look at it through the finder scope. The 6-degree apparent field. Now, software doesn't split it, but I believe you can split it in the finder. At least, if I remember correctly, it might be tough to do. So let's put an eyepiece in. Let's see, that's a 19mm panoptic. There's a 13mm Nacler. Now I know this star is splittable through those eyepieces. Software is not doing it, so let's zoom in a little more and see. Okay, I had to zoom in a little more with Stellarium, but you can see that Razel-Gethy has a bright gold member and a slightly fainter light bluish white member. So you've got a blue and gold pair here that are very similar to Albireo. So give Razel-Gethy a look. It's magnitude 3, and let's go over finding it again. Probably made it look harder than it actually is to find. You want to look for these 3 stars here. That's the bottom of Ophiuchus, and then this coffee pot shape here. This top star is Razelhage. And then you'll always see just next to Razelhage in the direction of Hercules is Razel-Gethy. And let's see, Razel-Gethy is just within the bounds of Hercules. You'll see it's actually not part of Ophiuchus. So yeah, this is Ophiuchus here, and this is Hercules. So this star right here, Razel-Gethy, or Alpha Hercules, is actually part of Hercules. One of my favorites. Okay, let's look for some more double stars that aren't quite as well known as Razelgethy. Let's look for Rho Hercules. And we can use our search here. And something I just discovered, I feel embarrassed. You can type in Rho Hercules this way into Stellarium. Or you can use the Greek letter alphabet here that's on in these little buttons here. So you can actually click the Rho symbol, leave a space, and type in HER for the three-letter abbreviation for Hercules. And either way will take you to it. So say you're looking at a star chart or something, or a list, and it's only giving you the Greek letter, you can find it here in Stellarium by just clicking on the symbol. So that's the symbol for Rho Hercules. Okay, this is a double star. Let's have a look at it through the Finder. And you can see Rho doesn't quite split at this magnification, but there is a really pretty double star here just below it. And you got a really pretty gold here, a pretty blue one. Hercules has a lot of really pretty colorful stars in it. So let's have a little bit of a closer look at Rho. Now it's listing it as a double star at magnitude 4.5, 401 light years away. And this one splits into two bluish-white stars. That would be a really pretty one to look at too. I don't think I've ever observed this one. Okay, let's reorient ourselves with the sky here a little bit. We've got Vega in the field. We've got the keystone of Hercules right here. And let's have another look at the constellation lines. Here's the keystone here. Here are the boundaries. So Hercules extends quite a ways out from the keystone, as you can see. Okay, let's look for another double star, 95 Hercules. And this one's listed as a 5th magnitude double star, 470 light years away. A satellite going through the field, that's pretty cool. And through the eyepiece, this one doesn't quite split, so we'll have to get in a little closer to split this one. But you can see again, this one splits into another blue and gold, light blue and gold. This would be another really nice one to show people. Okay, I've got one more double star on my list in Hercules, and that's 100 Hercules. Now, if you're curious where these double star lists come from, one good place to get it is from the Astronomical League. They publish a list of double stars. I think there's 100 of them on the list. And you can sort the list by right ascension and go through them season by season, or you can sort them by constellation. Okay, this one is 100 Hercules. And through the eyepiece, it looks like it's just starting to split. This one looks like it's going to be much easier to split. Yeah, this one's pretty easy to split. So this one will give you a nice wide. It looks like headlights in the distance or cat's eyes. I like those kind of double stars. Sort of like, more like Mizar and Alcor. Okay, we've returned to a naked eye field of view. Let's get reoriented with where we are. And again, we're looking really high up. This keystone of Hercules here this keystone here is very close to the zenith point. So you're looking almost straight overhead in early July at 10 p.m. at night. So as I said before, if that's too high up for your telescope to observe comfortably, you might want to wait a couple of hours when Hercules begins to drop a little bit lower in the west. Okay, those are the double stars I had listed. Now, no visit to Hercules would be complete without two of the grandest Messier objects in the sky. Two wonderful, bright globular clusters. And we're going to save the best for last, so I'm going to start with M92. And you can see how the go-to found it. Here's the keystone of Hercules. So you want to come off this star right here. Just go in this direction. M92 is a globular cluster about 26,000 light years from Earth. So again, this is a typical distance for a globular cluster. You have tens of thousands of light years away, forming sort of a halo around the middle of the Milky Way. So this is in a typical, in the kind of the realm of globular clusters. It's 6th magnitude, and let's see, I'm going to try it through my 19 millimeter panoptic, one of my favorite eyepieces. So that's what we're simulating here. And you can see that M92 actually is superimposed behind a field star that's almost like right in the middle of it. It's really striking. M92 doesn't get the attention that M13 gets. So we are going to observe M13. We're going to do it next. But I wanted to take you first to M92. Okay, let's get reoriented with where we are in the sky. M92 is right here. So you can go to this star here and this star here and kind of form a squat triangle. And you can see it's right here. It's actually more of an equilateral triangle like this, closer to this star. Yeah, there it is. Okay, should we try to find M13? Most amateur astronomers know where M13 is by heart, and it's a simple matter of looking at the keystone of Hercules, and you'll notice one of the stars is a little bit brighter than the rest of them, so that kind of guides you to which side of the keystone M13 is on. It's going to be on the same side as this one along the longer side, so that points you over here. And I believe it's about 2/3 of the way from this star to this star, so that puts it about there. So let's look through the finder and see if I'm even close. So let's move our scope in that direction. I believe I see. Yeah, at this point, what's nice about M13 is it's so bright that if you get in the neighborhood of it, you will find it. And I believe we're there. The Great Star Cluster in Hercules, M13 is magnitude 5.8, and it's located 25,000 light years from Earth. And let's look at it through our 19 millimeter panoptic, and it's absolutely glorious. I've spent many evenings looking at this globular cluster almost exclusively. So let's go over that locating one more time. This is something every amateur astronomer should know how to do by rote. So you can see where we are. Here's the square, the keystone of Hercules. Look for the star that's a little brighter than the other three, and that guides you to the side of the keystone it's on. It's going to be along the longer side. So that keeps you away from this side. That's why you find the brighter star. And then it's about 2/3, maybe 3/4 of the way from this star to that one. And by the time you put the finder on that in that area, You should be close enough to it where it's in your, even if you miss it, you will see an obvious bright spot. Oops. And then it becomes pretty easy to find at that point. So that's my tour of Hercules. I hope you have enjoyed it. Actually, I don't want to end this just quite yet. You thought I forgot, because I actually did. I like to make it dark before we quit. So let's do that. Having so much fun with these globular clusters, forgot to make it dark. So now we're looking in the direction of Hercules from a dark site. And you can see it's a little harder to pick out the keystone. It's right here. Here's the keystone right here. Here's the bright star Vega. Here's the keystone. And let's have a look at M13 from a dark site. So let's find the brighter star of the keystone. That's this one here. And let's go about 2/3 of the way between these two stars. And now it becomes real, from a dark location, it becomes really obvious. And there's a Stellarium simulated view of M13 from a dark site. Okay. Now while we're at this dark location, let's see if we can find M92. If I remember correctly, you want to come off this star and you want to form kind of a flat triangle with these two stars. So it's going to be about there, I believe. Ooh, I missed it a little bit. I think this is it out here. So it would have been just outside the field of view. So I believe that's M92. And Stellarium keeps wanting to pick a star instead of the cluster. That's okay. We'll still see it when we click on it. So again, this is a simulation of M92 from a dark site with these bright stars superimposed in front of it. So when you're looking out at M92, you're actually seeing these stars that are actually much closer. Let's see, like that one there. See, it doesn't give us the distance though, does it? There, M92, it does give us the distance to that, 26,000 light years. Okay, now that we've taken the time to venture out to a dark site and look at a couple of globular clusters, now we're ready to wrap it up. So again, I'm glad you joined me here tonight. Good night and good seeing.